And I'll start by reading it. You make hot chocolate in the microwave. What is the gain in energy if a cup 250 milliliters of tap water increases in temperature from 15 to 95 degrees Celsius? You want to know that for questions like these, you'll just assume that delta H is equal to Q. And for this, you'll be using this equation. So you'll check the things that you have. Let's go over them. You have the mass, 250 milliliters. You might confuse this with volume, but just know because that we're talking about water, H2O, you can automatically just put 1 milliliter as 1 grams. So 250 milliliters of water is the mass, which is 250 grams. And the specific heat capacity for water is just 4.19. That's something you'll have to memorize. And you have the delta T. You have the initial temperature, which is 15 degrees Celsius, and the final temperature, which is 95 degrees Celsius. And here I just plugged it into the equation, Q equals mc delta T. I put the mass, I put the heat capacity, and I put delta T. Just know that when you're plugging in delta T, it's T final minus T initial, not the other way around. And after that, I got the answer in joules. But to convert it to kilojoules, all you need to do is just divide by 1,000. And there you have your answer as 84 kilojoules. Okay guys, so here's the second example, and here in an experiment involving a burning candle and a can of water, the temperature of 100 grams of water increases from 16.4 to 25.2 degrees Celsius when the candle is burned for several minutes. What is the enthalpy change of the combustion reaction? So as we already know, we're going to assume that delta T is equal to Q equals mc delta T, and with that, I'll just list the things that we already have. Okay, so here I wrote everything that we have and the equation, and I plugged in the values into the equation, and we got the answer as 3,600 joules. So to convert this into kilojoules, as I said before, you'll divide it by 1,000. And because it's in so many weird decimals, it'll come out as 3.68 kilojoules. But to make it look nicer, we can just round up and say that it is 3.7 kilojoules. And what I want to mention is that because this is a combustion reaction, energy is being given off. And when that happens, it's usually denoted by a negative. So we'll put this value as a negative so that we know that the enthalpy change is exothermic. Okay guys, so that's it for today's video. Today's video is very short because enthalpy change is a pretty easy, like numerical questions are pretty easy for them to do by yourself. And the topic that will take some time is molar enthalpy because that requires equations and stoichiometry. So if you guys want to learn that next time, please comment and I'll make a video on that too. See you guys next time. Bye.